morning everyone. My name is Nurpa Kesari Rana and I am from IIT Dhanbad. Today I am going to discuss some questions on strength of material. So this is the question number 1. So the question number 1 says there is a homogeneous simply supported prismatic beam with width B, depth D and span length is L is subjected to a concentrated load of magnitude P. The load can be placed anywhere along the length of the beam. We have to find out the maximum flexural stress developed on the beam. And the option is option A 2 by 3 PL upon BD square, option B 3 by 4 PL upon BD square, option C 4 by 3 PL upon BD square, and option D 3 by 2 PL upon BD square. This is the question. There is a homogeneous simply supported beam. It has the width B, depth is D, and the span length is L. Okay, so let's do the diagram first. So this is a simply supported beam, like this, and the load is acting on the mid of the span, like this. This is the load. So what we have to find out here is the maximum flexural stress developed. Maximum flexural stress, that is sigma B. This we have to find out. Our option is given as 2 by 3 PL upon BD square, option B 3 by 4 PL upon BD square, option C 4 by 3 PL upon BD square, and option D 3 by 2 PL upon BD square. So this is our option. Okay, so let's find the solution. So to find out the maximum value of flexural stress, we have the formula as sigma B equal to M upon Z. So here M is the maximum bending moment. Maximum bending moment acting on the beam. So for that we have to draw the bending moment diagram first. So as you know that the bending moment on the simple support will be 0 in the simply supported case. So the bending moment here will be 0. And we have to find out the bending moment on the mid of the span. So the maximum bending moment will be equal to, the reaction will be, this one is P by 2 and this will be P by 2. So the maximum bending moment will be P by 2 into this is clockwise moment, so P by 2 into total length is L. That's why this one will be L by 2. So P by 2 into L by 2. So this will be PL upon 4. So this is the maximum bending moment occurring on the beam. So we have to represent it on the diagram. This will be like this. This will be linear, like this. And the value will be PL upon 4. So we got the moment first. And after that we have to find the section modulus. So Z is the section modulus of the beam. Section modulus of the beam. So we know the formula for the section modulus, that is I upon Y. I is the moment of inertia of the beam, and Y is the maximum value of maximum Y value, that is the distance from the neutral axis. This is the projection of the beam. This is the neutral axis. This is B and this is D. So we have to find out the Y. This will be D by 2. So I is the BD square, BD cube upon 12, and the value of Y max is equal to D by 2. This is D by 2. So BD cube upon 12 upon D by 2, that will be equal to BD square upon 6. So we got the value of section modulus as BD square upon 6, and we got the moment as PL upon 4. So we have to put that on the formula. So this will be PL upon 4 divided by BD square upon 6. So this is equal to, after calculating this, we can get it as 3 by 2 EL upon BD square. Okay, this is the value of sigma B, the maximum flexural stress, and this is our answer. And this is the option given in option number D. Okay, so this is our final answer. Okay, then let's move to question number 2. So question number 2 says, there is a beam of rectangular cross section. It is subjected to vertical shear force V, and the shear force carried out by the upper 1/3 of the cross section is. We have to find out the shear force carried out by the upper 1/3 of the cross section. And the option is given as option A 0, option B 7V upon 27, option C 8V upon 27, option D V by 3. So first of all, there is a rectangular cross section beam of rectangular cross section subjected to vertical shear force, that is V. We have to find out the shear force carried out on the 1/3 portion of the beam. Okay, so let's do the diagram first. This is the rectangular cross section of the beam, and this is the neutral axis. So what we have to find out here is, we have to find out the shear force developed on the upper 1/3 portion. This is the upper 1/3 portion. This is the hazard portion. We have to find out the shear force of the hazard portion, that is the 1/3 portion of the beam. So let it be the width is B and the depth is D here. First of all, we have to find out the shear stress. Okay, we have to find the shear force. That's why we have to find out the shear stress first. Tau is the shear stress. First, we have to find out the shear stress. Tau. So we know that the formula for the shear stress is equal to V into A y bar upon I neutral axis into B. So here V is the shear force, A is the area of the hazard portion, y bar is the distance of the center of the hazard portion from the neutral axis. This is y bar. And I neutral axis is the moment of inertia about the neutral axis of the cross section, and B is the width of the cross section. Okay. So this is V. We have to first find out the area of the cross section, the hazard portion, area of the hazard portion, and that will be equal to, as you know, this is D, then this will be D by 2. So area will be, the width is B, so B into D by 2 minus Y, this will be Y. So area will be B into D by 2 minus Y into, we have to find out the y bar. Y bar is the distance from the neutral axis to the center of the hazard section. So this will be equal to, this is y, so y plus, this is d by 2 minus y, d by 2 minus y divided by 2. Okay, up to this one. Okay, so divided by I N A into P. What will be I N A? The moment of inertia about the neutral axis. That will be equal to BD cube upon 12 for the rectangular section. This is equal to BD cube upon 12 into B. B is the width. So what we have to do? We have to cancel this. The B and B getting cancelled first. Okay. So after that, we have to solve this one. So this will be 12V upon BD cube. 12V upon BD cube. This will be d by 2 minus y. D by 2 minus y into y plus. This will be equal to d minus 2y upon 4. D minus 2y upon 4. Yes, d minus 2y upon 4. Okay. Okay, after solving this will be equal to 12v upon bd cube into this is d minus 2y upon 2 into this will be equal to 4y plus d minus 2y upon 4. Okay. So this 2 and this 12 will be getting cancelled. This is 6. So this will be equal to 6v upon bd cube into this is d minus 2y into this will be d plus 2y. D plus 2y and divided by 4. Okay. So what's next? So this will be equal to 6b upon bd cube into this is a minus b into a plus b, that's why it is a square minus b square. So this is d square minus 4y square. Okay, d square minus 4y square upon 4. So this is equal to 6b upon bd cube into, can we write it as d square upon 4 minus y square? So this is our value of shear force, shear stress. This is the shear stress. Okay, this is the shear stress we got. So after the shear stress, we have to find out the shear force. So let's find the shear force. What is the shear force? So the formula for the shear force will be tau into area will be B into dy. So we have to take a small section on the hazard portion. That will be this one. And this is dy. Okay, this is dy. So tau, we have to put the value of tau here. Tau will be 6v upon bd cube. 6v upon bd cube d square upon 4 minus y square into b into dy. And we have to integrate it. We have to integrate it from this portion to this portion. And this is equal to, as it is dy 2, this is dy 6 and this is dy 2. So we have to integrate it from dy 6 to dy 2. Okay. So this b and this b getting cancelled. So this will be equal to 6b upon d cube into d square upon 4 y minus y cube upon 3. And the limit will be dy 6 to dy 2. So this is equal to 6b upon d cube into this is d square upon 4 and here is y. So we have to put the limit in place of y. This is d by 2 minus d by 6 and that is equal to d by 3 minus this is 1 by 3 into y cube. Y cube means d by 2 cube, that is d cube upon 8 minus d by 6 cube of d by 6, that is equal to d cube upon 216. So this is equal to 6v upon d cube. This is d cube upon 12 minus 1 by 3. 8 is getting common from both the sides. So this is d cube minus d cube upon 27. Okay, after this is 6b upon d cube into d cube is getting common first. So we have to take d cube as common. So this will be equal to 1 upon 12 minus 1 upon 24 into this will be equal to 1 minus 1 upon 27, that is 26 upon 27. Okay, so d cube and d cube will get cancelled. So this will be 6b 1 upon 12 minus this one but 24. No, this is 26 upon 24 into 27. 24 into 27 will be equal to 648. 648. So after solving this, we will get as our final answer as 7b upon 27. 7b upon 27. So this is our shear force. The value of shear force will be equal to 7b upon 27. So this is our final answer. So shear force we got it as 7b upon 27, and this is given in the option number B, 7b upon 27. So this is the answer of both the questions. So I hope you got the answer of both the questions. Thanks for watching. Thank you.